factor in solving polynomial equations. Okay, we've dealt with quadratics. Now we're going to spread that out and move on to polynomial equations. A couple of special factoring patterns. The sum and difference of perfect cubes. So if I've got a cubed plus b cubed, it's going to factor to a plus b times a squared minus ab plus b squared. And then this trinomial will no longer factor. Okay. The difference of two perfect cubes is a minus b, a squared plus ab plus b squared. Okay. We're going to use these to factor completely, and then eventually we're going to use these things to solve. Because if you can factor it, and you can set each factor equal to 0 and solve from there. Alright, so starting with factoring completely. Now when you factor completely, that just means you're going to start with looking for your greatest common factor, and then see if it can keep factoring until you can't factor anymore. And when you can't factor anymore, you definitely will have all linear factors, or it'll be down to a monomial and binomials, that kind of thing. Alright, for this one, greatest common factor is where we start. Well, I got x cubed, 7x squared, 10x. I definitely can take an x out of there. So when we factor out the x, you're dividing by x, so this is going to be x squared minus 7x plus 10. And then to check to see if the trinomial will factor, are there factors of 10 that will add to 7? I didn't multiply the first and the last term this time because my coefficient here is a 1. If the coefficient is a 1, then you can just ask yourself the question, what are the factors of this that'll add or subtract to whatever this is? So if this is adding, it's got to add to this number. If this were subtraction, they would have to subtract to this number. There are factors that will add to 7, and those factors are 5 and 2. So this will factor to x minus 5 times x minus 2. Both of these are going to be the same, and they're both going to be a subtraction. Okay. The next one, we start with the greatest common factor. Okay. Greatest common factor of 16b to the 5th and 686b squared. Definitely can take a b squared out of there, and you can definitely take a 2 out of there. I tried to look at a 4 to see, because I know 16 is divisible by 4, but since 86 is not divisible by 4, therefore 686 is not divisible by 4. Okay. So factor out the 2b squared. That's going to leave us with 8b cubed plus 343. Okay. Now, this is a binomial, but there's something here that's going to draw my attention. My attention is going to be drawn to the b cubed. Okay. B cubed is a perfect cube, so then I want to look and I want to think, oh, is 8 a perfect cube? Yes, 8 is a perfect cube because 8 is 2 times 2 times 2. Perfect cube. Is 343 a perfect cube? Then you kind of got to test it out. So you can either do the cube root on the calculator, and we'll talk about that, or if you just want to try multiplying it out, it is a perfect cube. It happens to be 7 cubed. So to use the special product pattern, this is a sum. A is going to be, this is actually going to simplify to 2b cubed. So A is 2b. So everywhere there's an A, I'm going to put 2b. And then B in this case is going to be 7 because 343 is 7 cubed. So everywhere there is an A, I'm going to put 2b. And everywhere there is a B, I'm going to put a 7. This 2b squared is still there. It's going to be brought along for the ride. So this is going to be 2b squared. And then I've got a plus b. Well, a is 2b in this case. Plus 7. And then a squared, well, okay, 2 squared is 4, and b squared is just b squared, so this is 4b squared, minus 7 times 2b, so 14b, plus 7 squared, which is 49, okay? And I have never found the trinomial for the sum or difference of perfect cubes. This trinomial has never been able to be factored. Okay, next one. Factoring, another way to factor. Okay, we can factor by grouping. Now, when you have a polynomial that has 4 terms, so most likely it's going to be a cubic, or maybe it'll be different, it depends, but most likely it's going to be a cubic polynomial. It's got to have 4 terms. Usually, the terms that you're going to put together will be the first 2. You're going to group them. You're going to group the first 2 and group the second 2. And then you're just going to factor the greatest common factor from each of those. Now, the whole idea when you factor the greatest common factor is to end up with the same binomial when you factor the greatest common factor. Okay? So let's do this first one. And we're going to group these first 2 terms together. And I'm going to group these second 2 terms together. And we're going to factor the greatest common factor from each pair that we've grouped. Okay, so start with that. I've got x cubed and 3x squared. Well, I can take an x squared out of there. That's going to leave me with x minus 3. Okay. Now, when I factor over here, I want to end up with an x minus 3. Because then I got something times x minus 3, plus or minus something times x minus 3. And then we're going to factor the x minus 3. Okay? So, greatest common factor of negative 16 and 48, you always want to factor a negative if you can. Alright, especially since this first term is negative. So if we factor out a negative 16, because 16 goes into 48, so let's factor out a negative 16. That's going to leave us with x. Now 48 divided by negative 16 is minus 3. Oh, how convenient. Now I have x minus 3 and an x minus 3. Well, guess what? X minus 3 is the greatest common factor of these 2 terms. I took a polynomial that had 1, 2, 3, 4 terms in it, and now I've made it into a binomial because I've got this term and this term. Okay? So the greatest common factor between this term and this term is the x minus 3. So now I'm going to take that x minus 3 and write it out front. Okay, so x minus 3. And in parentheses, I'm going to write what's next to it. So I've got x squared minus 16. Okay, and I unfortunately wrote too big because the x squared minus 16 will factor even further, because that is the difference of 2 perfect squares. So we're going to continue factoring. The x minus 3 is a linear factor already. Once you get down to the linear factors, it won't factor any further unless you have a greatest common factor. But you should always do that first. Alright, so x squared minus 16 is going to factor to x plus 4, x minus 4. Now, that factors to this. If you multiply these 3 binomials, your answer is going to be x cubed minus 3x squared minus 16x plus 48. Okay, next one. It's another factoring by grouping. I see the only thing I can think of to do is to factor my first group, my first 2 and my last 2. Okay, that's usually how it's going to happen. Once in a while you might have to move things around, but usually it's going to be the first 2 and the last 2. Then you do your greatest common factor. Oh, x cubed, x squared. Okay, factor in x squared. That's going to leave me with x plus 7 here. Next one, yeah, definitely want to factor a negative out of there. So negative 9, because 9 goes into 63. That's nice too. And this is going to be positive x, negative plus 7. How convenient is that? I've got x plus 7 and an x plus 7. I didn't make my 7 very nice, did I? Okay, x plus 7, x plus 7. That's the whole point of factoring by grouping, to get those binomials. So I've got x plus 7 and x squared minus 9. Well, guess what? X squared minus 9. Difference of two perfect squares. So, x plus 7 times x plus 3, x minus 3.